Hello again. Let's continue with solving problems regarding internal forces, and I'm trying to cover in these recitation sessions some problems that I'm not able to cover in the classroom for lack of time. So let's touch this problem and see what happened. First of all, I'm going to put names to these connections here because I don't want to mess up later. So I'm going to say this is A and B because they are marked like that. I'm going to mark this point as C, D, E, F, G, and H. And this is a pin. Because this is a pin, it's going to have two reactions. One reaction, two reactions, and this is another pin, two more reactions, and this is going to be dy, dx, cy, and cx. And here problem comes. The first thing that I have to do, well, the problem is asking us, of course, calculate the internal forces and moments. Every time that I say internal forces, understand that I'm referring forces and moments at A and at B. The first thing that we have to do, once again, is calculate the reactions. And when we start doing the reactions, then we have to check that we have 1, 2, 3, 4 unknowns. So that means that we can't solve that. We cannot. But that's not entirely true. Because this element, even though you see it like that, is statically determinate. And we are able to calculate statically determinate elements. How do I know it's statically determinate? I know it's statically determinate in the same way that you should know. Remember, we saw in class something that is called the formula that allows you to determine that R equals 3n, where R is the number of reactions, counting even the internal reactions. So if this is like that, this is a pin, 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 pin. So I have 1, 2, 3, 4, 5, and 6 pins. 6 times 2, 12. So I have 12 reactions. And how many elements I have? I have 1, 2, 3, and 4. 3 times 4 and 12 equals 12. That means that this is statically determinate. So I can do it. But then I have to recur and I have to cut this section, and I have to separate the structure, and I have to find any mechanism that helps me with that. Well, what we have to do is realize, first we have to look at the structure, and then we have to realize the particularities of the structure. Look at this element, for example, and look at this element here, for example. If you look at this element, this is a pin, and this is a pin. This is an element connected at the endpoints by pins, and I don't have any force in between, meaning the forces on that element can be only either tension or compression. So the internal forces in this element has to follow this direction, because this is a two-force member. It works like a rigid link, it works like a member in a truss. Notice this is not a truss, but this element could behave like a truss member. Same thing happens here. If I have a pin here and a pin here, and I don't have any intermediate force, then the forces in these elements are going to come following the axis, only tensile or compressive forces. And that's what we're going to do, because now we're going to take this part and we're going to isolate that part, and at the same time we're going to isolate this part also, and then we're going to combine those equations that we are going to be finding. First of all, I'm going to calculate that angle because I'm going to need that angle. And that angle theta is going to be the inverse tangent of 2 divided by 1, which means theta is 63.435 degrees. I like to put decimals in the angles because, believe it or not, a small difference in the angles make a big difference in the forces. Okay. So I'm going to copy this part, the top part first. As the force. Remember, this force is 4 kilonewton per meter. I said this is cy, this is cx. This distance, we have it, but you see here, at this point, I have that force. That force, I'm going to call it the tension EF, and this angle is the angle that I just calculated, theta. Here, at this point, I have another force, and I know the direction is going to be like that because I already explained that this direction is going to follow the axis, this force, and so this force is going to follow the axis. So basically what we have is this, the distance from here to here is this, 1 plus 1, 2, and then you have 1 meter here. Notice that all the distances are in meters. I might be missing the distances, the units while I'm working it because I don't want to overcomplicate the drawing. But this is the drawing for this part. Now if I use this part, we have the bar, and we have the force EF in the same direction. I know it looks the face here, but this is supposed to be the same direction, EF. So if this is EF, this is the angle theta also. And then I'm going to have dy, and here is cy. dy, dx, and here is dx. What else do we have? This force, and then I have gh at the other end. Now this distance is 1, this distance is 2. And now we start working with our systems of equations, with that equation. Let's talk about the top part first. Summation and forces in x equals 0. Then we have cx minus the horizontal component of this one. The horizontal component of EF is this force here, and that force is EF cosine of the angle equals 0. I'm going to call that equation 1. Now summation of forces in y equals 0. In y we have cy, and the vertical component of this, which is the same one here, that's going to be minus EF sine of the angle minus GH. But also, remember, I have a distributed force here, which is going to produce a concentrated force of value 4 times 3, 12, and the location of that force is going to be half of the base because it's a rectangle. So here I have to subtract also 12 equals 0. 12 is 4 times 3, 4 times 3, the distance from here to here, 3. I'm going to call this equation 2, and then summation of moments at C equals 0. If we do that, then we have what? We have the horizontal component of this is not producing because passes through the point. The vertical component produces a moment, and the moment is going to be negative because it's going to be causing a rotation clockwise, and I assume counterclockwise positive. So it's going to be negative EF multiplied by sine of the angle. That is the vertical force multiplied by 2, which is the distance. What else? GH, negative also, times 3. And this force, 12, times the distance, 1.5, and also negative because it's in the same direction, equals 0. And I'm going to call this 3. So we have 1, 2, 3 equations. And you're going to say, why didn't you start from moment? You always start from moment. Yes. I always start from moment when I'm going to get something from moment. But if I start from moment, this equation, I also have 2 unknowns. So that's why I didn't start with the moment equation. Now let's go with the bottom part. You see, if I start with moment, I have 2 unknowns. I'm not going to do it. I'm going to go by, I'm going to call this equation 4, which is going to be summation of forces in x equals 0. Then we have dx plus EF cosine of the angle, because it's adjacent, nothing else, equals 0. Equation 5, summation of forces in y equals 0. dy plus the vertical component here is sine plus gh equals 0. And equation 6 is going to be summation of moments, and I'm going to do summation of moments at D equals 0. Horizontal component passes through the point, transmissibility principle. Vertical component, which is the same in this side, is going to be EF times sine of the angle times the distance, which is 1, positive, plus GH times 3 equals 0. And now look, how many unknowns do we have? We have 1, 2, 3, 4, 5, 6 unknowns. And we have a system of 6 equations with 6 unknowns. You can, if you want to, put these organized in your calculator and solve it, but you don't need to, because if you just check your equation superficially, you don't have to do any thorough revision. Look at this equation, this equation and this equation here, 3 and 6. My unknowns are EF and GH. So basically what I have with these two is a system of 2 equations and 2 unknowns. So I'm going to work with 3 and 6. Equation 3, we just did it. Equation 3 is here. It's negative EF sine angle times 2 minus GH times 3 minus, I'm going to multiply this, 18 equals 0. That's equation 3. Equation 6. EF sine of the angle times 1 plus GH times 3 equals 0. Equation 6. Well, I can get those 2 equations and add them up, and these cancel out, and then I have negative EF sine of the angle, and I pass this to the others, or negative 18 equals 0, and I can calculate EF then, because EF is going to be equal to negative 18 divided by sine of the angle, and my angle is 63.435 degrees, which allows me to calculate EF as negative 20.124 kilonewton. There you go. We are starting to see the light at the end of the tunnel. First of our unknowns. What do we do after that? We plug this back into here, or into here is easier. If I plug this back into here, this value multiplied by sine is going to be 18, because that's, I divided before by sine, right? So I plug that here, it's going to be 18. Remember the signs. It's going to be negative. I'm going to plug this in 6 now. So it's going to be negative 20.124 multiplied by sine of the angle plus GH times 3 equals 0. So GH is going to be equal, I pass this to the other side, 18 divided by 3, 6 kilonewton. Now, what do we do? Look at your equations. I know EF, I know GH. EF, if I put EF here, I can calculate CX from 1. here. Cx minus EF cosine of the angle equals 0. So Cx is going to be equal to EF cosine of the angle. So Cx is going to be equal to, EF is negative, warning, negative 20.124 cosine of the angle. Cx equal negative 9 kilonewton. Now what do we do? Well, let's go back to our equations. If I go to the second one, Cy, and I know EF, and I know GH also. So, from 2, Cy minus EF sine of the angle minus GH minus 12 equals 0. I know EF, I know GH. Once again, if I put this value here, remember to put it negative, multiply by negative is going to be positive, and this is going to be 18, positive 18 here. GH is negative 6. So I have 18 minus 6 minus 12 equals 0. Cy minus, that means that Cy is 0. What else? Now I go to equation 4. Yeah, I can calculate dx from 4. I can calculate dx, and dx is equal to 9. I'm not gonna solve it. I solved it, but I'm not gonna do it. From 5, I can calculate, remember 5 is this equation. I know this and I know this. This is 18, negative 18, and when I multiply, I mean. And GH was 6, so that means that it's going to be 12. From 5, dy equals 12 kilonewton. And I have 1, 2, 3, 4, 5, and 6. I have my 6 unknowns. And now is when we're going to start working with our problem. Once you have your unknowns, the problem is nothing, because what we have to do is calculate what? Internal forces at A and internal forces at B. Let's go to our point A. Where is my A? This is A. So if we go here, and I have to do internal forces at A, let me start with B because I don't know. That's my OCD speaking here. I'm going to make a section here. So if I make a section there, in that part, what we have is basically at point B. So we're going to have this, the load on top of it, Cy. How much is Cy? We calculated Cy. 0. I don't put Cy, but just for you to know. Cy is 0. Here, this is C, remember, and this point is B. Cx, negative 9. Danger, Will Robinson. Danger. Negative. We assume it in this direction originally, but it's negative. Goes in this direction. And the value is 9 kilonewton. And of course here I'm going to have my shear at B, my axial at B, and my moment at B. Guys, it's important, super important. Once again, I'm going to use this from the other problem, the drawing that I did. Don't try to match any number because I'm not looking for the numbers, I'm looking for this. Look at that. This is the direction, the positive direction. You use this side, which is the one that we're using. The positive convention for shear, axial, and moment is that. That is important. And this distance from here to here, we had it as 1 meter. If this is 1 meter, this force was 4 kilonewton per meter. It's going to produce a force here, which is going to be 4 times 1, so it's 4, and the distance from either end is 0.5. Now we're done. We just do summation of forces in x equals 0, negative 9, plus A axial at B equals 0. That means my axial at B equals 9 kilonewton. Summation of forces in Y equals 0. Then I have the vertical force coming from the distributed loading is negative 4. Negative my shear at B equals 0. My shear at B is going to be negative 4 kilonewton. And if I do moment, I'm going to do summation of moments at B equals 0. Moment here. I have this force multiplied by this distance, which is 0.5, and it's counterclockwise, which is rotating in this direction. What I said is positive. So it's going to be 4 times 0.5. And my moment at B minus MB. Remember, I don't have a vertical force here. That's why it doesn't produce anything. Plus MB, because it goes in the same direction, equals 0, and MB is going to be equal to negative 2 kilonewton per meter. Done. What are we missing? We are missing now at B, at A, this part. Well, if I had to do summation of forces at this part, I'm going to make a section here, but I'm going to isolate this. Why? Because I know this value. It's like making a section really here in this part. This is the point A. And that's what we're going to do. So I'm going to draw that part. This is my force at that end, GH, equal, how much was GH? 6. This distance from here to here is 1. And basically, once again now, look at the direction that you will use here for the positive. Well, here has to be the opposite, because we are using the other end of the element. This is going to be my positive shear. This is going to be my positive moment. This is A, not B. And this is going to be my positive axial. And that's it. Summation of forces in X equals 0. A, my axial at A is 0. Summation of forces in Y equals 0. V, my shear at A, plus GH, which is 6, equals 0. So my axial, my shear at A is negative 6. And summation of moments at A, then this is MA, which is going in the opposite direction to my summation convention, negative MA, plus, because this is going to do this movement, 6 times 1 equals 0. So MA equals 6 kilonewton per meter. So we calculated axial shear and moment at B, and axial shear and moment at A. Try to solve these problems, guys, all the time, but solve them by yourself. And if you get stuck, go back and check it, because I always mention some things that can help you out to increase the speed of the problems or some tricks for solving it easier. See you in the next video, guys. Have a good day.